Okay, now some of these problems I wrote are really pretty stupid, like sounding problems and all that. Why anybody would want to know that? That's not the point. What I'm trying to do is get a skill down that's going to become kind of important later on because the problems get a little more sensible. So you have one problem at the end of this packet. You need to do that one. It's a problem. It talks about the dolphin. Okay. Yeah, the dolphin. Okay. First, you better watch me do a couple. Startled armadillo jumps straight into the air with an initial velocity of 14 feet per second. After how many seconds does it land on the ground? Okay, so my two units are the feet and the seconds. That's what they're going to be on all the problems. X is going to be our seconds, and Y is going to be our feet. So per feet per second. And we know that that is 14. So far, starts off innocently enough. But here's the thing. Don't write this down. Just watch. In what world does something jump up in the air and just keep on going up for infinity? It doesn't. Also, in what world does something curve up into the air and just go for infinity when it jumps in the air? It doesn't. According to the laws of gravity, what goes up must come down. Okay? So this is what is called a parabola. P-A-R-A-B-O-L-A. Parabola. Now, when you have a parabola, you need to mark where it lands, the ground, and put 0 feet right there. That's all you need to do. Now you're like, well, how do I write my equation down here? You need to follow the formulas that I give to you, and you have this sheet of paper, and here's our first formula. It's called the gravity formula. Gravity, time to the second, plus velocity, time equals height. Okay, so what's the first thing we have? Gravity. We are always going to use the number -16 for gravity, so write that down. Then after gravity is going to be time. Time is x, so x to the second power. Don't put that stupid parentheses there I just said. Plus velocity. Well, the velocity is that feet per second we came up with, which we knew was 14. And then I'm going to have the time again. But that's x, but that won't be to the second. It'll just be x. And then my height is equal to y. Now, 0 feet. The feet is y, so 0 is going to go right here. Okay? And that means there are going to be two answers for x because I have an x to the second and an x. Okay? Okay, now, so in order to find this, we have our 0, so now I set up my GCF box. So GCF, do you have a negative in front? Yes, you do. Do you have x, and then you underline your terms, x squared and x. I want to take x out of that, and 16 and 14. If you know the GCF right now, put it down. If you don't, come out right 14. So 1 and 14. 14 divided by 2 is 7, so 2 and 7. And that's it. If you divide by 3, 4, 5, and 6 are all decimals, and then you're back to 7. Now, can you divide 16 evenly by 14? No. Can you divide 16 by 7? No. Divide it by 2? Yeah. So negative 2x is coming out here, okay? So that's going to be factor number 1. Okay, so negative 16 divided by negative 2 is positive 8. X to the second divided by just a single x means you'll have an x left over. Positive 14 divided by negative 2 is negative 7, so minus 7. And then the x, the same kind of x's divided, just cancel. And that is factor number 2. So factor 1, negative 2x could equal 0. Factor 2, 8x minus 7 could equal 0. So I divide by negative 2, divide by negative 2, and that's 0. Plus 7, 8x equals 7. Divide by 8. Now, I told you before you could just leave it 7 over 8, but on a story problem, I would like to see the decimal rounded to the nearest hundredth. So 0.87, and then that 5 would make it 0.88. Now, let me explain the meaning of the solutions. Those are the answers, but here's the meaning. Here's why there are two of them. You got to understand that it's going to be at 0 feet here, but it's also going to be at 0 feet where it starts. Well, when it starts, if somebody had a stopwatch, they wouldn't have ran it when it starts. So that's why we get our first answer, because there'd be 0 seconds. And then he jumps up, comes back down, and then after that, 0.88 seconds have passed. Okay? That's what those mean in that situation. So look at from 0 to 0.88. The real answer is 0.88, not even 1 full second. Okay, next problem. A fat penguin jumps out of the water while swimming at a velocity, make it 4. I don't like those decimals. 4 feet per second. After how many seconds does a penguin land back in the water? So again, we have feet and we have seconds. So that's x and that's y. So I've got per feet per second, okay, which is 4. But again, a penguin doesn't just go up for infinity, so it needs to be up and down. It's a parabola. Now, we want to know when he lands in water, so 0 feet. Now, he also starts at 0 feet too. So he was in 0 feet at 0 feet 2 different times during the jump. Okay, now let's set up our formula again. Gravity, negative 16. Time, x, power of 2, plus velocity, 4, x equals height y. But we will be putting these 0 feet in for y, because y is feet. I'm trying to find the seconds that go with that feet. I'm expecting this to be a 0. I don't know what that's going to be. Okay. GCF, do you have a negative in front? Yes. Do you have x on both? Yeah, you do. So x. Okay, 16 and 4. 4 would be the one to go to. 1 and 4. And then 2 and 2. I'm pretty sure you can divide 16 evenly into 4. So 4. So negative 4x is our GCF. And I will be pulling out negative 4x. And that's going to be positive 4x and negative 1, so minus 1. And then those cancel, don't forget that. So that's factor 1, that's factor 2. So negative 4x can equal 0, or 4x minus 1 could equal 0. So I divide by negative 4 and I get 0 for my first answer. Plus 1, 4x equals 1. Divide by 4, x is 0.25. Okay? So again, these two answers, 0 seconds and 0.25. I don't really care if you put this up here. I'm just explaining how it works. So when you goes up, jumps, and boom, he's down. So that's gone from 0 to 0.25. On a stopwatch, 0.25 is the real answer. Okay. A cat leaps from the ground into the air with an initial velocity of 11 feet per second. After how many seconds does the cat land on the ground? So I've got feet and I've got seconds. X is seconds, Y is feet per. Feet per second is 11. Again, he will go up, but then he will come back down, okay? 0 feet, 0 feet. I'm trying to find the seconds that go with those. I'm pretty sure that's got to be 0 seconds, but how about the other one? Okay, so again, gravity, -16. Time, x second. Velocity, that's up here, that's your feet per second, 11. Time, x. And then equals my height, which is y. Now again, those 0 feet, we just plug in for the y. And then we got 2 answers we will be finding for the x. Okay, so GCF, so underline, underline. You have a negative in front, so make a negative. You also have x in both places, so x. And then let's check 16 and 11. 1 and 11, but the problem is 11's prime. There's nothing else that's going to divide by 11 by. Now, you're like, so what do I do? Well, what you're going to do is you can definitely divide them both by 1. Now, a lot of times, I just put a -1x here. So -1x, and that's going to be F1. And -16 divided by -1 is +16. X second divided by x is x. +11 by -1 is -11. So I minus 11, and those cancel. Okay, and that's F2. So -1x equals 0. 16x minus 11 equals 0. So I divide by -1. X is 0. And I plus 11 to both sides. 16x equals 11. And 11 divided by 16 would be 0.68, but it'd go to 0.69. Okay, 0.69 is the true answer. Because here it's these answers I got are the seconds that correlate to these feet amounts. Well, nobody cares about 0 seconds. What we care about is when it's going up. Okay. Again, a lot of these answers problems are silly and all that. Okay. I'm not going to do this one because I already did one where you had 14 feet per second, and I'm also not going to do this. Fine, I can do this last one. A spittlebug jumps into the air with an initial vertical velocity of 10 feet per second. After how many seconds does the spittlebug land on the ground? So I've got feet and seconds. X is seconds, Y is feet. So per feet per second is 10. Okay, now you got to remember it's going to go up, but it's going to come down. That path is known as a parabola. And we want to find when it's on the ground. So it's on the ground in 2 places, 0 feet, 0 feet. So -16x squared plus 10, again, sorry, I'm going too fast. Gravity, -16, time, x, second power, plus velocity, the feet per second from up here is 10, and then the time is x equals your height. Okay, that's y. Okay, put your 0 feet in for y, and there you go. Okay, GCF, you have a negative in the front. You have X on both. 10, 1, 10. 10 divided by 2 is 5. 3 and 4 are decimals, and then that takes you back to 5. Well, I don't think you can divide 16 evenly by 10. Or 5. Probably can do 2, though, so negative 2x. Okay, so negative 2x comes here. That's positive 8x and negative 5, but then that cancels. Okay, F1, F2. So I know that there are two answers to this problem. So negative 2x could equal 0, or 8x minus 5 could equal 0. So I divide by negative 2, and that gives me 0. Then I plus 5 plus 5. 8x is going to equal 5 here. I divide by 8, and 5 divided by 8, 0.63. Okay, so then up here, of course, I look at this. 0 feet is going to correlate to 0 seconds, and then 0 points. And when it gets back to 0 feet, we'll have passed over a half second. Okay, you have the one problem about the dolphin now. I will tell you this, the answer is not going to be a decimal. It's going to be a nice solid number.